on to the greatest common factor. And I think this is something that you probably have seen or talked about a little bit before, but we are going to go a little bit in depth, and we're just kind of reviewing this because we're all building to into doing prime factorizations, prime and composite numbers, and all of this is leading us into a discussion on fractions. So eventually, probably either right before Christmas or maybe right after Christmas, we are going to start into our unit on fractions, which I know you're all very excited about. So let's go ahead and discuss the greatest common factor for now. The greatest common factor, also known as the GCF, is the greatest factor that two or more numbers have in common. So it seems kind of self-explanatory. So let's look at 36 and 64, because I think looking at an example just helps us kind of solidify what this is saying. So looking at 36 and 64, what we want to do is we want to list all of the factors of 36. Remember, a factor is a number that goes into 36. So 1 goes into 36, 2 goes into 36, 3 goes into 36, 4, not 5, 6, 9, I skipped over 9, and then 12, 18, and 36. So really kind of what happens here is when you get through the single digits, eventually you're going to hit a point where you're then going to start going back down. So 6 times 6 is 36. 4 times what is 36? Well, 4 times 9 is 36. 3 times what? 3 times 12 is 36. 2 times what? 2 times 18 is 36. 1 times what? 1 times 36 is 36. So let's do the same thing with 64. So it goes through 1 is 2. Remember, if you don't know offhand, go through our divisibility rules from the last lesson. So here, 6 plus 4 is 10. 10 is not divisible by 3, so 64 is not divisible by 3. 4 is divisible by 4, so we know that this whole thing is divisible by 4. Not 5. It's not divisible by 3, so the whole thing is not divisible by 6. We didn't do 7. It is divisible by 8. So 8 times 8 is 64. 4 times what is 64? Well, it's 4 times 16. 2 times what? 2 times 32. 1 times what? 1 times 64. So then our question then, what is the GCF between these two numbers? The GCF is going to be the biggest number that they both have in common. So they both have 1, they both have 2, they don't have 3, so it can't be that. They both have 4, and then it stops. No 8, no 16, 32, and 64. So the GCF for this particular problem would be 64, because it's the biggest number that will go into both 36 and 64. So let's go ahead and take a look at a few other examples of how we can use the greatest common factor. So let's take a look at something like (36) and 54. So we're going to call this example number 1. 36 and 54. So again, we're going to go through and do the factors of each, which 36 we just did, so we already know those. Now 54 we're also going to have to do now. So let's go through our divisibility rules. Well, 1 we know is always there. Even, so it's 2. 5 plus 4 is 9, so that means it's 3. 4 is divisible by 4, so it's 4. 2 and 3, so that means it's 6. Not 7. 8 is not 8, because 54 is not divisible by 8. 9, because 5 plus 4 is 9, so we know that works. So now we're kind of on that backward slope. 6 times 9 is 54. So 4 times what gives us 54? Well, that's actually going to be 4 times 14. 3 times what? That's going to be 18. 2 times what? That's going to be 27. And then 54. So now we go through 1s, 2s, 3s, 4s, 6s, 9s. So those are all the same. So right now it's 9. 14 is not shared. 18 is shared, and that's the last one. So our GCF here then is going to be 18, between 36 and 54. We can also do this between 3 different numbers. The only thing we have to do is find the factors of all 3 numbers. So let's take a look at something. Let's say 12, 18, and 15. Some of you may be able to look at that and just know. But let's go through and look at each factor. So we have 1, 2, 3, 4, 6, and 12. So these are easier to find. You guys should know what these are divisible by. So this is 1, 2, 3, 6, 9, and 18. And then 15 is divisible by 1, 3, 5, and 15. So now we need numbers that are in all three numbers. The only one that occurs with is number 3. So the GCF of 12, 18, and 15 is 3. Alright, let's do one more. So let's take a look at the numbers. Let's take a look at the numbers 6, 55, and 60. So 6, because it's so small, kind of limits us. So that we know is only 1, 2, 3, and 6. So when we go to 55, that's only 1, 5, 11, and 55. None of those overlap except 1. And if 1 is the GCF, so if I look at 60, 60 is going to have a whole lot more. So looking at these, this one has a whole lot more. So even though the 2's are the same, the 3's are the same, the 6's are the same, those numbers aren't here. So because that's the case, our GCF is just 1, or you could say none. Because sometimes you might see it where they say there is no greatest common factor, because 1 is just always there, so it's not really counted sometimes. So you may see where that happens as well, that you may not have a greatest common factor between 2 numbers. So that sums up this lesson. Again, this may have been a review for some of you. This may have been, oh, I kind of remembered that, but I wasn't quite sure. Again, all building up to our fraction discussion coming up in a few weeks. So make sure you have those down, and that this is what we use our divisibility rules for, is to determine. Let's go through and list all the factors, so we have to know what it's divisible by. so that we can figure out our GCF.